evening. Welcome to Spaceplace's third online event, where we will be bringing the benefits of Canadian space technology down to Earth. I'm Kirsten Vanstone. I'm the chair of the Spaceplace Events Committee, and I'll be your host for this evening. We hope that you may already know what Spaceplace is, but in case you don't, we are a group that is dedicated to building a major planetarium in the city of Toronto. Did you know that there are the only two large major cities in the world that do not have a major planetarium are Toronto and Sydney, Australia. And once we're done here in Toronto, I propose that we start working on Sydney. The pandemic has put a few of our plans on hold, as I'm sure many of you are familiar with, but we've been working since last fall to bring you online events that tell the stories of Canada's contributions to space and to astronomical science. There's a lot of stories to tell, and frankly, as a country, we're just not very good at bragging about our accomplishments. Spaceplace hopes to start changing that. This endeavor takes a lot of work, and before we can build our dome, we need to build a network of helpers, volunteers and members, and of course supporters willing to donate a bit of cash towards our operations. If you are interested in membership, there are a few options for you. I'd like to tell you about that by showing you some of our membership structure here. If you are a member and would like to renew your membership, if you already are a member, please do. You can do that for $50, and for a limited time offer, if you renew tonight, we'll send you one Planetarium Music download card. So if you're a fan of Planetarium Music, one of our volunteers, Richard McDonald, has contacted some of the old composers from McLaughlin Planetarium and gotten some of their music available for you. It's a little bit of nostalgia. So if you are not a member, and you're interested in becoming a member, please let us know. You can email us at spaceplacecanada.ca. I will actually get the email address and put it up on the screen. And send us a note and we will tell you what being a member entails and how much it will cost and all of the wonderful things that you can do to help us in our attempts to get this planetarium built in Toronto. But even without a planetarium, we have a lot of things to talk about. And tonight, I'm really excited to meet the people that I've actually been able to meet putting this program together. Really interesting folks, and we'll get to that in a minute. But I want to start with some of the people who've helped support Spaceplace along on our journey. And in particular, I'd like to thank MDA. MDA has been a sponsor of this online program. And to start off our evening, I would like to show you a little video that MDA has put together. If you are a fan of space and live in Canada, you probably know MDA. They've got a long and storied history here and are embarking on a new chapter. And I really like this video that tells the story about what they're up to now. And let me pull it up. Isn't that great? I love that video. It really gets me in the mood for what we're doing tonight. Just before we move on to our actual speakers, I would also like to acknowledge our other supporters. We have supporters in Global Public Affairs and Stradia who are helping us get the word out about our project. Okay, now down to business. We have 3 speakers with us tonight. Starting off, we have Ian McLeod. He has come to us tonight from MDA. He's worked for over 25 years in space and related industries, and he is currently the Vice President International at MDA, Canada's largest space company, as you saw. Ian has a master's degree in electrical engineering from UBC. He specialized in digital signal processing and then got an MBA at Queen's University. His current focus is on MDA's expansion into international markets. So I'm going to add Ian up to our screen here. Then next we have Eric Choi, and Eric has worked for over 20 years in the aerospace industry. He's currently a director of business development for Canada-US government at GHGSat. You're going to hear about that tonight. It's a really interesting company. And he also has a degree in engineering science. He's got an aerospace engineering degree and a master's degree, both from the University of Toronto. And he got an MBA at York University. So you can see business and space coming together here. You may also know Eric from his science fiction writing and editing. Here's Eric. And then we have Meena Mitri. Meena co-founded Kepler Communications in 2015. He has served as its CEO since that time. He liaises with senior stakeholders to devise Kepler's business vision and financing strategy. And under his leadership, Kepler was named one of the most innovative companies in the world by Fast Company. And it has become the largest satellite operator in Canada. It's a pretty amazing story. Meena also holds an MASC and BASc in aerospace and aeronautical engineering from the University of Toronto. And I just want to say that as an alumna of U of T, it's really nice to see you guys representing. That's really great. Sorry, Ian.
That's okay.
That's okay. So here are our speakers for tonight. We're actually going to start tonight with Ian McLeod. We're going to move on to Eric Choi and then Meena Mitri, who are all going to tell us about projects that they are working on right now. So we'll start with, if I may, the granddaddy of them all, MDA, and hear about a current project that Ian would like to tell us about. So I'm going to bring up all of that. We'll see Meena and Eric and me later. Over to you, Ian.
Did you manage to bring up my small presentation there, Kristen?
There you go.
Kristen? Okay, I'm going to assume that you guys can see that's on my screen right now.
We can all see it on your screen, yeah.
Perfect, thanks. So I'm going to try to keep this very brief. I just wanted to present a couple of things to the group. I'm going to talk a little bit about synthetic aperture radar. One of the key applications that MDA has developed over the years. But to do that, I'm going to try to first sort of level set everybody on who MDA is and what we're doing, and then talk a little bit about the theory behind synthetic aperture radar, the technology, just so you understand where how the technology works and what it's used for, and then talk a little bit about the history in Canada of the RadarSat program. So just to give you a very brief look at MDA, refresher for some and maybe new information for others. MDA, as mentioned, is Canada's oldest space company, founded in 1969. The heritage actually goes back even farther than that if you look at some of the missions we participated in, but that was when the company was founded out in Vancouver. As you can see from the screen here, it's trying to summarize all the various types of missions that we do, and it's quite diverse. And probably the best way to walk you through it is to talk about the different groups within MDA and what they do. And we really operate in sort of 3 major centers across Canada. So if I start out in the east in Montreal, Montreal is where our satellite systems group is. And the satellite systems group, as their name implies, builds systems for satellites, and in some cases are doing full satellite projects. And this graphic down in the lower left-hand corner with the 300 plus missions, that's in reference to them. They've been involved in many, many space missions, either supplying equipment or participating in the full mission at the prime level. And you know, if you've received DirecTV at home or spoken through the Ridium satellite network, chances are you've been speaking through some equipment that was provided by that group out in Montreal. If we continue sort of to move west to Brampton, just outside of Toronto, that's where MDA's headquarters is, and that's where our Robotics and Space Operations Group is located. And the Robotics and Space Operations Group is probably best known, as MDA is probably best known, for the Canadarm. And you can see the picture of the Canadarm on the space shuttle where it first flew. That evolved to the Canadarm2, which is located currently on the International Space Station. And the exciting news at MDA recently is that we have been contracted to build Canadarm3. And Canadarm3 will be the contribution of the Canadian Space Agency to the NASA Artemis program, and will eventually be used on board the Lunar Gateway, which will be orbiting the moon. So super excited in the work that we're doing on that. The other thing that the Robotics and Space Operations Group does is exploration missions. And they've been involved in many, many exploration missions over the years. And this is an area that's really taken off, I'd say, in the past decade or so, as more and more countries have become active in space and more exploration missions have been developed. And so doing things like rovers and robotics on space probes and various other things is another part of that group's business. And if we continue even further west to Vancouver, where MDA was initially founded, that's where our geointelligence group resides. And the geointelligence group, as the name implies, is really about extracting intelligence from Earth observation data. And so that's the group where they use the data from our RADARSAT-2 satellite, and they fly the RADARSAT-2 satellite. It's the group that takes data from other sources as well, combines it with radar remote sensing, and turns that into intelligence products and applications that can be used by our customers in order for them to perform their business. That group is also where we have ground stations manufacturing, and MDA operates or has customers around the world that operate our ground stations. I think we are at last count over 70 ground stations around the world. So it's a very diverse group doing lots of different types of things in space. And the journey of MDA has been interesting too, and has been quite rapid in the last several months. And we've been around for a long time. Some of you may remember we were part of Maxar. Maxar was a US entity that MDA created and became part of as part of a US access strategy. But that changed in 2020 when we came out of Maxar and again became a Canadian company, privately held. A company called Northern Private Capital put together an offer and purchased MDA from Maxar. And so for about a year, we were a private entity. And then just recently on April 7th, we completed our IPO. And so we are once again a publicly traded company in Canada. So that's MDA. And where I'm going to be focusing my discussion is really on that sort of top left of the diagram, which is a series of the RADARSAT satellites, which I'll talk about. But before I get into the actual missions, I'm sure that in our audience, there's different levels of knowledge about what synthetic aperture radar is. So here's your 2-minute introduction to how SAR works. So synthetic aperture radar, as the name implies, is a radar imaging technology. And what that means is that rather than using the light that's reflected off the ground, as you would with an optical image taken from space, of the nature you'd probably see on Google Earth if you looked at a picture of your house from space, radar instead supplied its own illumination. So you can kind of think of it as if you're in a dark room and you had a flashlight and you flash the light over at an object. You're just seeing the light that's reflected back to your eyes. You're not seeing general illumination from sunlight. And so that means that there's a number of unique properties with radar remote sensing. And the most important one is because it's supplying its own illumination using microwaves, you choose a frequency band in the microwave spectrum, which is transparent to clouds. And also because you're providing the illumination, just like my example of a flashlight in the darkness, you don't care whether it's dark or light out. So radar has the property that it can see through clouds and darkness, meaning you can image at any time, regardless of the conditions, the atmospheric conditions or the light and darkness conditions. So that's obviously a really useful feature for a number of applications where you just really have to be able to see what's on the ground. And you can vary the parameters. You can vary things like the polarization, the wavelength, various characteristics of the energy you're sending down to the ground in order to illuminate and understand different features on the ground. And so you'll hear things, a little diagram in the lower right there, X band, C band, L band. These are just essentially bands of spectrum in the microwave spectrum that different missions will use. And because they're different frequencies and have different wavelengths, when you analyze the return signal, you can pick up different things about what's going on the ground. And so, as that implies, there's some significant signal processing that needs to be done in order to take those raw radar returns that get reflected back to the satellite, which is 800 kilometers up in space, and then turn that into something that you can actually visualize as to what is on the ground. And what you get is really a radar reflectivity map. It looks like an image, and you can see some examples in the very small examples there in the top left, these sort of black and white images, which look a lot like an optical image, but the best way to think of them is they're a radar reflectivity map. So things that are bright means that it reflected a lot of radar energy back to the sensor, and things that are dark means that the energy bounced off the ground and went away from the sensor, so the sensor never received any energy back, and so it's dark. So this unique characteristic lends itself to a number of different applications. So it turns out you can do a really good job detecting ice, and you can even classify ice to understand how old it is. And it turns out that's really important if you're an icebreaker captain trying to navigate in the Arctic, or frankly, if you're studying things like climate change and understanding how ice is changing. As you can imagine, if you are beaming energy down and there's a ship there with a nice metal hull, it reflects the energy back very brightly, and so it's very good for picking up ships on water. Similarly, in the opposite sense, oil is very smooth. Oil allows energy to be reflected away, and so oil appears very dark in the image. And so, for example, when the Deepwater Horizon accident happened, the radar imagers that we operate were very, very active working for the US Coast Guard and BP as they tried to coordinate the response, because we could pick up over very wide areas how the oil had moved. And of course, it didn't matter if there were clouds, we could actually see through the clouds to see where the oil was. And the last one I'll comment on is things like land deformation. Because again, you control the energy that goes down to the ground, you can measure very precisely how things change over time. And as it turns out, using a technique called interferometry, you can actually measure sub-centimeter changes in the position on the ground from 800 kilometers up in space. And that has applications for looking at things like urban stability. As groundwater gets drained for drinking water, the ground begins to subside, and you can detect that from space and identify where infrastructure might be affected. And there's a number of other applications as well. So that in a nutshell is how radar works. So you're using active illumination from space. So turning to Canada, it turns out that Canada is an expert in radar technology and synthetic aperture radar, and this heritage goes back a long way. It actually started with missions that were flown in the Arctic monitoring ice, and they were using aircraft. And in the early 90s, late 80s, someone had the idea of saying, well, wouldn't it be more efficient if we did this from space, because we cover much larger areas and we don't have to fly the aircraft around. And that really led to the genesis of RADARSAT 1. And the really foresight the government of Canada had when developing RADARSAT 1 was it was developed for the government of Canada in applications that the government of Canada thought were important, but they also built a commercial arm to it. And so in 1995, when RADARSAT 1 launched, it became the first commercial SAR satellite. And there was a company called RADARSAT International that was created, eventually became part of MDA, and their job was to go out and commercialize this data. So having the vision that this data could be used commercially was first done in Canada, and RADARSAT 1 was that pioneering mission that was launched then. That also led on the MDA side to rolling out over 50 network stations, and these are the ground stations around the world, because as customers came online and said, well, I really find this data valuable, one of the things they wanted was to receive it very quickly. And so to do that, they had their own ground station. In addition, one of the examples there, you can see Antarctica. So again, studying the ice, studying how climate is affecting the polar regions is one of the things that RADARSAT 1 was used for. And RADARSAT 1 flew for over 17 years. So it was a very long mission. In 2007, which overlapped with the RADARSAT mission, RADARSAT 2 was launched. And RADARSAT 2 had a unique business model because it moved even further down the commercialization. And this was a public-private partnership between MDA and the government of Canada. So MDA actually contributed to the mission. And in exchange, the way the government participated was they did an advanced data buy. So they contributed money towards the construction of the spacecraft and received payment in imagery that was received over the life of the mission. So RADARSAT 1, as you can see from the picture, looks an awful lot like, or RADARSAT 2 rather, looks a lot like RADARSAT 1. And that's intentional because it was a continuity mission. So it contained all the same modes that RADARSAT 1 had so that our users would have continuity. But it also added a whole bunch of new features, new polarizations, wider swaths, new commercial modes that we could use that we could tune specifically for the needs of various customers that we had developed over the course of the RADARSAT 1 lifespan. So, and part of that, for example, was essentially optimizing the operations to do very quick tasking and very quick delivery, which enabled a lot of sort of operations that required the satellite to tip and queue another asset. And then finally, as we move forward to 2019, we developed the RADARSAT Constellation Mission, RCM. And you can see those satellites look a little bit different, and they're less capable satellites than RADARSAT 1 and RADARSAT 2 on their own, but there's 3 of them. And the reason for doing that was essentially to get more revisit and more coverage. And so these satellites are in polar orbits, so they're going around the Earth every 90 minutes. And by having 3 of them, you can get a lot more revisit, and you can, if you spread them out in a smart way, you can get sequential coverage that allows you to cover more area. And the mission was designed really to get daily coverage over Canadian areas of interest. And that's the little chart you see at the bottom, where the light blue is daily coverage, and then you can see you get higher and higher coverage as you move further north because the satellites are again in a polar orbit. And so that takes us up to sort of present day. The RADARSAT Constellation mission is currently flying. And just a month ago, MDA announced publicly that we will be rolling out the next STAR mission in Canada, which we're cleverly calling SAR Next at the moment. We'll come up with a better name. But in the meantime, we're calling it SAR Next, and we started working on this many months ago now. And we're not releasing a lot of details yet, so I can't tell you too much about what it's going to be about. I can tell you that one of the key objectives is to continue with continuity of the users that we have. So we will be using our C-band technology. The RADARSAT satellites work in that C-band. Remember the letters from the earlier slide. And so we will be continuing that. We will be continuing some of the features that were in the initial RADARSAT satellites, but we'll also be adding a bunch of new features that we've heard from our existing customers that they would find valuable. So that'll be coming out. The launch is scheduled for 2024, and stand by as we release more details on that in the coming months. So that was all I had. So back over to you, Kirsten.
Thank you very much, Ian. We've already got some questions coming in. Just to let you know, everybody in the chat on YouTube, we're going to be taking the questions at the end. So I'm sure Ian is going to be able to take those. But right now, what I'd like to do is move on to our next speaker. And that speaker is Eric Choi, who's going to tell us about GHGSat. Here you go, Eric. And your slides. There you go.
Just like that, Kirsten. Thank you so much. It's really a pleasure to be here this evening, presuming that, of course, it is evening if where you happen to be on the planet. So I'm Eric Choi, and I'm from GHGSat, which is one of the newer space companies. So MDA, as Ian has explained, has been around since 1969. We were founded in 2011. And yet there is, I think, some commonality of purpose between not just ourselves and MDA, but many other players in the Canadian space field. The video that we saw at the opening there, one of the things that came up in that video that really struck me was the notion of a future that protects our planet. And that strikes to the very heart, the very purpose of what we at GHGSat are trying to do with Canadian space technology. So, as I said, the company was founded in 2011 in Montreal. And the genesis of that, or the motivation, was that the founders of the company recognized a need. So around that time, in the early part of the last decade, there were indications of subnational jurisdictions, namely California and Quebec, were in the process of implementing a carbon pricing scheme. This was, of course, quite revolutionary at the time, but is gaining acceptance with more and more subnational, of course, national jurisdictions as well around the world, the notion of putting a price on carbon, which is all well and good. But one of the challenges facing that is, how do we know that people are paying a fair price for for their emissions, because many of these emissions are based on estimates. They're actually not based on direct measurements. So this was the niche that was the mission of GHGSat to fill, to use space technology and thereby become a global reference standard for measuring greenhouse gas emissions at any place in the world, basically. So we're still headquartered in Montreal. I'm actually here in Toronto myself, but we have offices now in Ottawa, where our analytics group resides, in Calgary, and most recently we introduced or opened rather international offices in Houston and London, England. We launched our first satellite. This was a demonstration satellite in 2016. This was called pler. And this was invaluable as being a technology pathfinder for us, making sure that the innovative sensor technologies that we had developed for this application really worked. Now, in the previous presentation, Ian explained to us about synthetic aperture radar and the part of the electromagnetic spectrum that they use for that. So for our application, we use a different part of the electromagnetic spectrum. We operate in the shortwave infrared, and it's not radar we use, but an optical technology called a wide-angle Fabry-Perot spectrometer. And so what this spectrometer does, looking in the shortwave infrared, is it has sensitivity in absorption bands particular to methane. In fact, the demo satellite pler in 2016 also had some sensitivity to carbon dioxide. But methane is the gas that is the primary focus of our business plan at the moment. And the reason for that is very simple. In many ways, it's interesting that when we talk about climate change and we talk about emissions and greenhouse gases, the one that everybody talks about is, of course, carbon dioxide, as they should. And in some ways, perhaps, methane is sort of the forgotten greenhouse gas. And it really shouldn't be, because, in fact, methane, sort of kilogram per kilogram, has 80 times the global warming potential of carbon dioxide over a 20-year period. So that's sort of the bad news. The good news is, if we were diligent about mitigating methane emissions, what it means is that we can have a tremendous impact in mitigating climate change in the very near future. And this is exactly the application that we are targeting as instrumental to our raison d'etre, really, and to our business plan. So following the success of pler, of the demonstration satellites, we now have pler plus 2 commercial operational satellites in orbit. IRIS, which was launched in September of last year, and Hugo, which was launched in January of this year. And in case you're wondering where the names of our satellites come from, they're named for the children of our employees. So it's just a little way for us to remember and to remind ourselves of the importance of what we're doing, thinking about our impacts today on future generations. We have, we continue to expand. We have our next 3 satellites are under construction as we speak. And our eventual goal is towards a 10 satellite constellation. And this is driven by exactly the point that Ian had raised earlier about the importance of revisit, of being able to look at transient events by seeing things on a repeated basis over the course of several days. I regret that I don't have a very good picture of our satellites, but there's a bit of a cartoon there at the top left that you can see. The radar satellites that Ian had described earlier, these are just phenomenal things. They're these amazing things that are rather large. They weigh several tons in cases. Our satellites are a bit of the opposite side of the spectrum. So the 3 satellites that we have now and the ones that we're building, they're about 15 kilograms and basically of the nanosatellite class. And you can think of it, if you took a bit of a size comparison, it's about the size of a microwave oven. But even with that, we can, as I'll show in subsequent slides, we think we can do some pretty interesting and pretty amazing things. So who's our customer base? Who are the people who need to know about their greenhouse gas, their methane emissions? Right now, the most important user base, important customer we have is in the oil and gas sector, both from the standpoint of regulatory needs and also from the standpoint of operations and resource management. Because if you have a leaking gas well, that's not just an environmental problem, but that's dollar signs going into the atmosphere. That's product that's going into the atmosphere, and ultimately lost revenue. And this is where space really brings value to the problem. If you've ever seen a region of the United States called the Permian Basin, there are literally, you can Google this, and there are wells as far as the eye can see. It's really kind of an amazing sight. It looks like another planet in some ways, literally thousands and thousands of wells. And you can imagine that in that type of a situation, it's simply not practical to have a person holding an optical gas imager driving a truck around trying to examine each and every one of those in any sort of timely or regular manner. And this is where our technology through the satellites and also an aircraft-based sensor that we offer that's based on the space technology really adds values to these customers in the energy sector, where we've got the big picture from space, and we can then efficiently, these companies can direct the inspections and direct their repair efforts exactly to where it's needed. Some of the other customers that we've engaged and have interest in our capabilities, the waste management sector is another one. Landfills, for example, are significant emitters of methane, as are mines. So methane is vented from things like coal mines, for example. And this is important from the standpoint of safety. Methane is not toxic, but it is an asphyxiant and also an explosion hazard. So it's important for mine operators to be able to quantify the methane inventories at their sites. One of the ones that was quite interesting to me, because I was not aware of this before I joined GHGSat, is that power generation for things like hydroelectric dams are in fact significant or can be significant sources of methane. And this was something that, as I said, I didn't know initially. I was in the impression that many people have, that hydroelectric power is very clean, and it is. But the interesting part is that it's in the reservoirs behind the dams, in situations where you have biomass that's degrading in the water, and as that water goes through the dam and through the sluices, this methane and these gases come out of solution and into the atmosphere. And these are the things that we're able to measure from space using the GHGSat technology. So let's look at some pretty pictures, look at some examples of what these methane plumes look like. Now, to be clear, the plume itself and what we measure with the spectrometer is a column concentration. And that's the colorful part of these images. So the rest of the image, what we've done is we've overlaid it into Google Maps or Bing or other optical sources. So what you're looking at on the left is a gas rig in New Mexico. The capability that GHGSat brings to bear on this is that we're able to look with a high degree of both spatial precision and low detection threshold. So we're able to look at emissions as low as 100 kilograms per hour out of these sites. And the real differentiator is also the spatial resolution. So our spatial resolution is just 25 meters. And this is in contrast to other satellites, primarily government satellites from NASA and the European Space Agency, which are primarily the primary purpose of those is for scientific research and not for the applications that we're looking at, where a user and a customer needs to be able to attribute an emission directly to a facility. And that's something that is not possible with another instrument that, say, has a resolution of several kilometers, but is certainly possible when we're looking at images or being able to attribute down to 25 meters on the ground. I mentioned that in tandem with our satellites, we also now offer an aircraft version of our sensor. So this is flown on an aircraft, and this is something that is very complementary. And this is important because we see our technologies as fitting into other capabilities and reinforcing and complementing those. So at the lowest level, as I said, you have the person on the ground with a handheld sensor that goes around. We have our satellites in space, and now we have this aircraft sensor that sort of fills the niche in between those. So I said that the resolution of the satellite sensor is about 25 meters. Depending on the altitude, we can get down to about a meter on the aircraft sensor, and the detection threshold is about 10 times better. So it's about 10 kilograms per hour is sort of the lowest emission rate that we can detect on the aircraft sensor based on local wind conditions. So just some examples here. What's interesting is that the Delaware Basin is in fact not in Delaware. It's actually part of this Permian Basin formation that is a part of Texas and New Mexico. So again, you're looking at oil and gas facilities in these regions. I'll wrap up here with a bit of a fun toy that you might be interested in playing with after this event and after this presentation. Is we offer a pretty neat and free interactive global methane concentration map called Pulse. So if you go to pulse.ghgsat.com, you can bring up this map, and there's a slider at the bottom, and you can zoom in and out, and you can step through time and see how methane concentrations have evolved over the course of about the last year and a half or so. So the data actually goes back, I believe, starting to about January of 2020. And it's also very interesting actually to see how and where methane concentrations have evolved over the course of time, and perhaps interestingly over the course of the pandemic over the last year or so. So Kirsten actually outed me on something. Was one of the other things I dabble in is science fiction. And one of the hazards, perhaps, of our job and the profession that we're in is that many of us are science fiction fans. And the thing that really got me into this business, into this industry was, as with so many others, was, of course, Star Trek. And the thrill of exploration, of boldly going where no human has gone before, was obviously something that resonated greatly with me. But the other part of Star Trek, I think, that really resonated with me was the idea of an almost utopian Earth, of a peaceful and verdant and clean and environmentally sustainable society right here on our home planet that enables us to have, as if you will, a bit of a launching point towards these greater adventures. And ultimately, this is what makes me so proud to be a part of GHGSat, to be using space technology for the direct benefit of the environmental remediation of Earth, a future that protects our planet, as the MDA video had said. So let's talk. Let's continue the discussion, and let's talk about how we bring the Canadian benefits of Canadian space technology to Earth. Thank you.
Fantastic. Thank you, Eric. As someone who was actually watching Star Trek over dinner tonight, I think that's a wonderful thing. Okay, before we get to questions, a lot of questions coming in. Before we get to those, I'd like to get to our final speaker this evening. So see you later, Eric. And please welcome Mina Mitri and Kepler Communications.
Hello, everyone. Those are probably two very difficult acts for me to follow, but I'll do my best. I'm the co-founder and CEO of Kepler Communications, and I'll spend a little bit of time on mostly describing the differences in Canadian space now compared to what we've seen in the past, and a little bit about what Kepler does in representation of that. So Kepler was more of an entrepreneurial journey that was bred out of university endeavors and completely a bit of a departure from the traditional space sector. So the traditional space sector, as you guys might have known or seen in the past, has largely been driven by government mandated intentions or government need. And what we're seeing in the advent of what GHGSat just presented and what we have here at Kepler is much more of an entrepreneurial journey driven by a problem solution space that we're looking to address and a need that we've identified out in the marketplace. Something that's entirely unrelated to the government and may have applications that benefit the government. And certainly in all cases, there are applications for the betterment of our world here on Earth. Kepler as a business was started rather rapidly and changed very quickly through the course of the past few years. It was really bred out of PhD work and work we were doing within a nonprofit within the University of Toronto, where we used to design and build rockets, drones, and satellites for competitions around the world. And it's through that formative experience where we got exposure to all the major space problems, all that was going on in the space sector and the space domain that led to the ultimate ambition and the understanding of what was going on in space and helped us to found and build Kepler to what it is today. And today Kepler is I'm proud to call it a Canadian-based vertically integrated satellite communications provider. So we go end to end from the initial design, planning, and operations of the satellite, all the way through to delivering a service to an end user in the satellite communications domain. And I'll talk a bunch about the different satellite communication services that we end up offering onto the network and how we go about delivering those services in a little bit more depth. But over just a few short years, just to compare and contrast to kind of the heritage of MDA that was shown earlier, where MDA was kind of bred out in the 1980s, 1990s out of even just thinking about their synthetic aperture radar applications and eventually turned commercial. The entire ambition that was built around Kepler was predominantly commercial in nature and over a much shorter time scale. So that's what we're seeing is a dramatic shift in the space sector altogether. Today, we count 80 people at Kepler, and I think I saw a few comments there. We're always hiring and looking to grow the team. We'll roughly be looking to double in size over the next year. We now count the largest satellite communications constellation that's been built in Canada, with 15 spacecraft on orbit today delivering services around the world. We're serving our customers globally, and we operate in a very different part of the electromagnetic spectrum here, those that are used for bands and communication. So we operate services in the KU band, and for those of you that don't follow that particular nomenclature, that's the 10.7 to roughly 14.5 gigahertz frequency band range. And then we also operate services in roughly the 2 gigahertz range. And these choice of particular electromagnetic spectrum, unlike the applications that were mentioned earlier for largely Earth observing, where you're looking to measure properties of the Earth, ours are predominantly centered around communications. So how do we provide two-way information flow both up and down to the Earth? And that's the choice of spectrum that we operate in, and it's a little bit different. Electromagnetic spectrum is allocated on its particular use. So our spectrum is allocated specifically for communications, where some of the other bands that my previous colleagues were talking about were dedicated towards Earth observing in the applications that they describe. So the underlying problem that our network looks to solve is a problem of communications, not just on the surface of the Earth, but rather communications outside of the surface of the Earth. So I put up a little graphic here that describes your traditional satellite trajectory. An example case might be the RadarSat constellation or the GHG satellite that you just observed. When they orbit the Earth, roughly every 90 minutes in their orbital period, going from North Pole to South Pole, they have this intermittent window when they can communicate. So you'll notice that our colleagues at MDA went out to highlight that they've got 70 different ground stations distributed all around the world to be able to download the data that they collect from Earth observing. And that's largely because there's only intermittent periods where you're able to download this data. And with space access becoming more available today, really driven by a reduction in launch costs, this problem is becoming ever more prominent, where companies that are launching to put up more satellites into Earth orbit that are either imaging the Earth, collecting synthetic aperture radar data, or collecting weather data, what have you, they can only download that data very infrequently. And roughly 70% of that satellite's life is kind of in a communications black hole. So they're unable to download the data that they've stored on board the satellite. And you can imagine that the problem extends beyond that, where data is now delayed to get back to its ultimate users. If there's a nice navigation application and there's an urgent need on a ship to collect that information in short order so they can navigate their future path, a delay in downloading the data from the satellite directly impacts when that end user will be able to service or receive the information that they're after. And the space economy is expanding ever so prominently these days, where we're expecting the economy to reach about $1.4 trillion by 2030, which is something that even by today's standards is an enormous statement to be able to make. All this has been unlocked by massive reductions in launch costs. So launch is about a quarter of what it used to be even 5 years ago. And all these assets that are going up into space will have a fundamental need for communications, where today there doesn't exist, call it a robust internet infrastructure outside of Earth for all these assets to be able to relay their information back down to Earth in real time. And over the next decade, we expect to see something like 10,000 small satellites that are launched into low Earth orbit, counting the sum of GHGSat, the RadarSat constellation as Canadian-born innovations, but also quite a few around the world that we don't recognize today. There is an active effort to introduce space tourism into the market, and that's a net new innovation using low Earth orbit. And as you guys are all aware, there's lunar gateway ambitions, private habitats that are going up into Earth orbit, and we should expect to see the first humans landing on Mars. All this driven by massive reduction in launch cost, but desperately in need of a real-time communication solution to either relay that information that's collected in low Earth orbit back down to the Earth in real time, or communicate amongst satellites and space habitats all up in low Earth orbit and beyond. So what we're doing at Kepler is rather simple. We're putting up a mesh network of small satellites. You can think of them like Wi-Fi hotspots or routers around low Earth orbit, and they'll enable any spacecraft within low Earth orbit to communicate and relay information back down to Earth in real time. We do this with many different satellites, upwards of a few hundred satellites that will be operating in low Earth orbit. And for perspective, our satellites are roughly the size of a loaf of bread. They're significantly smaller, they don't occupy much mass, and they are responsible in their use of space, being able to safely deorbit, avoid collisions, and at the same time, not affect any of our astronomy groups with the relatively small size of our satellites. I think I mentioned at the start of my presentation that we do this all from the heart of downtown Toronto. So we have a vertically integrated facility where we go from design to production, all the way to reaching into Earth's orbit with these really small satellites. Our facility in downtown Toronto can deliver upwards of 10 satellites per month. That helps us to achieve the goal of having many hundreds of satellites to enable that whole mesh network out in Earth orbit. These satellites are roughly 1/10 the size of your traditional spacecraft, so they're very small by comparison, and we replenish them every 5 years to make sure we embed them with the latest and greatest in technology. So unlike most traditional space programs that take 3 to 5 years in design and are meant to operate in Earth orbit for about 8 to 15 years, we replenish our satellites every 5 years to make sure we adopt the latest processors, the latest in memory, and the latest compute, knowing that in telecommunications, there's a lot of advancements that happen pretty rapidly year on year. And just for some fun perspective here, I thought I'd draw down the analogy to an Iridium satellite. So on the left-hand side, you see what an Iridium-sized spacecraft would look like, roughly 940 centimeters across, and our satellites are about 100 centimeters across. And what we do, because of our satellites being so small, we can rapidly iterate the technology, unlike what's been done before. So if you take a look at, even the short history that we've had Kepler's network in operation, we've gone through many successive satellite iterations, and each one are producing a different function or utility out into the world. So just in 2018, we launched our first 2 spacecraft named Kip and Case after the robots in the movie Interstellar. And both of those satellites were meant to specifically test our software-defined radio and a high data rate backhaul communications link. So how do we get our data down from the network to Earth in a very timely way? The core innovation that we flew on there was a software-defined radio. And just by analogy, what it does is it enables us to convert what were formerly functions that were done by a radio in hardware down to software. So you can think of it like a big computer that goes in and takes an analog waveform and tries to decipher what language it will use that analog waveform in to provide a communication service. So that was the first core innovation that was bred out of some of our PhD work to fly it out into Earth orbit. Most recently, we saw the launch of our Generation 1 constellation, which has a consortium of different names that was all built up from an internal naming competition, ranging from C3PO to RM-RF, representing our software engineers. And in this first generation of satellites, it marks our initial service, where it's providing not quite communications for outside of Earth orbit, but an initial service that's providing communications to and from the ground, testing key technologies that we want to improve on. On board of our Generation 1 satellites, we have phased array antennas. These are antennas that are electrically steerable rather than mechanically steerable. So the antennas are able to point without having to physically move the satellite or orient the satellite in a particular direction. We also have on board of them the ability to move data between our respective satellites. And then as we continue to launch successive constellations and generations, we see rapid and dramatic improvement in what features they have to offer, sort of akin to what we're used to seeing here with iPhone releases or any new technology release. But we're replicating that out in space, which is something that's really incredible to see and something I'm very proud to do here in Canada. In December of this year, we'll have our Generation 1.3 launched, and then our Generation 2 going up between 2022 and 2023, where similarly we'll be making announcements around what new features and upgrades we have with a wide variety of changes going into the network, improving it for the betterment of those applications we intend to serve outside of the surface of the Earth. And with time, we'll continue to launch successive generations, marking about 200 satellites that'll be in our network by 2023, building up towards our longer term ambition of internet in space. So really all I wanted to highlight here is the dynamic changes where space is becoming much more entrepreneurial compared to the historical paradigm that's been government led. Here in our ambition, it's driven by a problem solution space that we've identified, focused in on communications, unlike some of my colleagues who are focused in on Earth observation. And we're very excited to kind of showcase this company we've been able to build here in Canada as a vertically integrated from end-to-end initial ideation to delivery of communication service. And that's something that, we're getting to see more and more as space access continues to get reduced. So excited to be a part of this Canadian Space Panel, excited to answer any questions. And if you guys want to chat, please look us up and reach out to us here at Kepler.
Fantastic. Thank you very much, Mina. So we have, before we put this event together, I'm just going to pull you off for a sec, Mina. Hang on a sec. There we go. Before we put this event together, we sat down and came up with questions that I could ask in case we didn't get any good questions in the chat. We've had a lot of really, really good questions coming in the chat. But before we get to those, I do want to just explore a couple of things that I skipped over in my introduction. So again, Space Place, here we are. We're trying to build a planetarium where you could actually gather in person and hear all these wonderful speakers at some point in the future. Just want to let you know that if you're interested in membership, it is $50. It's a limited time offer if you actually join. Sorry, that says renew. I forgot to update that. We'll send you a planetarium music download card. If you'd like to support us a little bit more, here is the chair of our Space Place board, Henry Lowton, modeling a beautiful 3-layer mask. I don't know how much longer we'll have to wear them, but if you want one, $75, which is a membership plus $25 donation. And you'll also get the Planetarium Music download card. And finally, for $100, $50 membership and a $50 donation, we'll add a book by Bob McDonald. If you're lucky, you could even possibly get it autographed. Also, I just want to let you know, you can actually do all of this by going to spaceplacecanada.ca and click donate by PayPal. Make sure when you do that to include your email address so we'll know how to contact you. And if you would like to actually learn more about us or want to connect with us and ask questions, you can email us at info@spaceplacecanada.ca. All right, so that's enough of the PBS style pitch. Let's bring our speakers back and get to the chat. All right, we had a ton of really, really good questions come in. I think I'm just going to launch into them because especially I was really gratified to notice that we seem to have a lot of students and new graduates who were very interested in whether or not any of you are hiring. Which is always a good thing, considering it's May and everybody's graduating. Mina, you mentioned that you're always looking for people. Eric, do you know what's going on at GHGSat? Are you in growth mode or?
We are absolutely in growth mode. So over the course of the past year, we've actually doubled in size. We're up to 85 people now from 42. and we are absolutely hiring. So please check out our website, GHGSat.com. You can find us on LinkedIn and all the other old people social media platforms like Twitter and Facebook as well. We're always looking for great people.
Excellent. Maybe you can hire someone who'll get you on TikTok.
Yeah.
Ian, how about MDA? I imagine you're always out there.
And we are in crazy hiring mode right now. I wish I'd known that question was coming. I could have had the stats, but we have hired hundreds of new people over the last several months. At the back end of 2020 and the front end of 2021, we have a number of major contracts that came in. If you want to know more about them, you can check out our website and the news releases. But it means that we have to staff up like crazy. So we are in a hyper growth mode right now, and there are hundreds and hundreds of positions that are being filled.
That is fantastic news. I'm sure many of our audience tonight will be glad to hear that. Okay, so I'm going to sneak in one of my questions here. This is one that Mina actually brought up, and I think it's timely based on the news of the last little while. There's a lot of chatter on social media about, which I'm on old people's social media, so Twitter. There's a lot of chatter about all these things going into space and how there's a lot of potential for debris and perhaps uncontrolled deorbits. And I think that people who may not be, well, people who are interested in space want to make sure that this isn't going to become a problem. I'm just wondering if you'd like to comment on that. Mina, this was the question you suggested. So space debris, what goes up, then what happens to it?
For sure, really great question. So let me start by the obligations we carry in putting up anything up into Earth orbit. The United Nations, they monitor and manage the situation. They say at first, anything you put up into low Earth orbit, you've got to take it out of low Earth orbit within 25 years. Anything you put into geostationary orbit, you've got to put into a graveyard orbit within some defined period of time. So that's one level of scrutiny. Below that, we also have a level of scrutiny towards our own regulators, where we provide our own service. So that's with the Canadian government, with the US government, with anywhere our satellites are providing service. With the Canadian government, we've got to demonstrate the safe use of space. We have to show orbital debris collision probability below 0.001%, which is a NASA-driven threshold around where we have to either be maneuverable or make sure where we're launching has a low probability of collision. So right now it's looking pretty good because we have a few things in space, despite what those graphic images show in most social media or public media. There's a lot of space between the things in space, pun intended there, and so it's pretty large. But with time, one of the major concerns would be the uncontrolled space debris. There's a nut or a bolt that flies off of a satellite, and while there's a large amount of space between you and that object, there's a probability you guys will collide just because you have no way of controlling that. So there's a lot of active debris removal efforts that are going on. I'm sure my colleagues are more aware of that than I can speak to it. And those will come with time. But I kind of see in our lifetime that this is going to be something we have to address as a problem. Just right now, we've got such a mass amount of separation between our objects that it's not the largest concern, but it's certainly something we need to be aware of and working to the proactive and safe use of space.
Fantastic. I wanted to get to that right off the top because, as you know, my kids were asking me about it, so I figure it's something that's a big deal. Do Eric or Ian, do you want to comment on that at all?
I think Mina summarized it really well. I mean, and the thing that's new in this area is the fact that there's just so many satellites that are planned or on orbit right now. Mina showed a slide there talking about 10,000. That could actually be on the low side if some of these big constellations come into being. So. So while it's great that the cost of launch has come down and that enables a lot more people and companies and countries to participate, it means that it has to be done in a very responsible way, not to cause problems.
I actually want to ask about that. So can you just outline for those of us who are kind of not as involved, why has the cost of launch come down so much?
Anyone of my panel members want to take that?
Got rocket people here.
The answer in simple terms is SpaceX and Elon Musk. So pioneering that ability to reuse rockets really does bring the cost down. And you've seen two trends, I think, come together. One is that pioneering of new ways to launch things that brings the cost down inherently. but important. And to Mina's point earlier, you've seen the commercialization of space activities, which means that instead of a launch being a big government program, a launch is a commercial program, and commercial methods come to bear on that, which also drives the cost down. And so these two trends of commercialization and finding new ways to do things go together to create lower launch costs.
That seems reasonable. Yeah, Eric?
I'll add as well is that the technology is a bit different, and perhaps not in the way that's intuitive. Is what is the remarkable breakthrough of a lot of these new launch providers is that they're not doing high tech, or they're not necessarily maximizing performance. They're basically designing to cost. So if we were to look at something like the SpaceX Falcon 9 rocket, it burns liquid oxygen and kerosene, which is something that is much easier to handle than something like the space shuttle that used liquid hydrogen, for example. The other part of it is flight rates and sheer quantities. So the launch of the SpaceX Falcon 9 in January, this was the Transporter-1 mission that our satellite Hugo was on, and I believe, Mina, there were like 10 of your Gen X's, or Gen 1s rather, were on that one. There were 133 spacecraft going up at the same time. Wow. on that one vehicle. So obviously you're able to amortize out the costs there.
That's a really important point, because as both Mina and Eric were talking about, the satellites they're working on are much smaller. And so you pack those together and suddenly the cost per satellite comes down quite dramatically. Right.
That's very interesting. I hadn't thought of it that way, but that makes sense. Pack more in and up you go, right? I have a couple of questions that are related to this being Canadian endeavors. Eric, you say GHGSat has offices in 3 countries. Mm-hmm. And just curious about how this projects the image of Canada on the global stage. We're looking at greenhouse gas emissions. Obviously, there's an interest in mitigating the effects of climate change. And first, before we do that, we have to be able to measure it. So can you comment about what kind of image this throws to the world? And then as a sort of related question, Luke asked, commercial capabilities that you need to go abroad for that you wish were available in Canada. So here we have sort of a two-sided question. Okay. So let's start with the, measuring greenhouse gases and GHGSat on the global stage.
Well, image is important, and being able to be seen to be actively mitigating climate change is important. But we would like to think that there is much more than an image that is related to the siting of our offices. So in fact, there is a reason, there's a specific reason that we are where we are. So as I said, our headquarters are in Montreal. Our analytics group is in Ottawa, taking advantage of the Canada Tech Corridor that's up there. I mentioned that we have a complementary aircraft-based sensor. So that stage is out of Calgary. And that's the primary purpose of our Calgary office, is to service the energy sector in Western Canada. And ditto for our office in Houston, being close to our customer base in the US energy sector, the Texas and the Permian Basin area. The one that is newest and perhaps is the most one of the most interesting is the London office, and that is, if you will, our beachhead into Europe, and I mean Europe, sort of writ large and geographically, not necessarily you, of course, but it's known, of course, that Europe is one of the world leaders in mitigating climate change, and it also addresses another market that we're looking at, and that is the financial sector, because there will be an increasing demand for what are called ESG metrics, so environmental sustainability governance metrics, where people are going to, and investors are going to be willing and will pay a premium for products that they know have a superior, or rather lesser, carbon or environmental impact than something else. One ingot of aluminum or one cubic meter of natural gas from the Montney in British Columbia is this much cleaner than the equivalent cubic meter of natural gas, say from Central Asia. So these are the reasons we're located where we are. And I'll say as well that there is also an important staffing and team building and diversity consideration there too, because the further we're spread out, the wider net that we're able to cast, and being located in these great places all over the country and all over the world means that we can cast a wide net and bring in the most diverse and talented people that we can. Could you please remind me of the second part of that question?
So Luke is asking, what commercial capability do you need to go abroad for that you wish was available here? Which is kind of a loaded question, but I think one that is, reality, right? We're not that big a country.
That this might have been a setup, because the one thing that is missing in our endeavors is that currently there's no capability to launch from Canadian soil. To speak frankly, that I don't think has been a big impediment to date in terms of our ability to get things into space. Just speaking for ourselves, we've launched the most recent one, Hugo, on the SpaceX. The previous one was launched on the European rocket called the Vega, and then prior to that, the demonstration satellite pler actually went up on an Indian PSLV rocket. But I do understand that there are, perhaps outside of the scope of this discussion, there are people working on trying to bring a launch capability to Canada, and I think that's going to be an exciting development to watch. Other than that, what is exciting, and I think what people should be aware of, is literally everything else can and is being done in Canada. So Mina and Kepler being a great example of being totally integrated to be able to design, test, integrate, test, build, operate a satellite from downtown Toronto. We don't build our own satellites. We have partners do that. But the satellite itself, the sensor, the ground stations, the operations, everything except the launch can be and is done in Canada. And I think that that's something that we should all be quite proud of.
Yeah, and so go ahead, Mina.
No, I was just going to say, and to build on that point, it's actually at a pretty rudimentary level of what we have access to here in Canada. So just talking a little bit about COVID, our supply chain remained pretty well intact because most of our suppliers were here in Canada. Everything from the people that were manufacturing our circuit boards to cutting bare metal and the types of things that people who had to have international suppliers would have been affected by. So certainly we have access to a lot of great stuff here.
Yeah, and what I'd add to that is it's been amazing to watch that evolve over time. So it wasn't always like that, and I don't have the numbers at my fingertips, but if we look back at RADARSAT-1 and measured the Canadian content of that satellite to RADARSAT-2 to RCM, it is consistently increasing. As more and more suppliers come online, they get involved in the program. That leads to them being involved in the next generation of the program. And so to Eric and Mina's comment, we're seeing just about everything being done in Canada. The supply chain is quite deep. And it's super exciting when you have, entrepreneurial companies like Mina starting up and then deciding they're going to manufacture, right in downtown Toronto. I find that amazing. So it's really great.
So, you're right, Eric. It was a little bit of a setup because we are planning another event in June that will be about the business of space and how Canadian space entrepreneurial stuff is happening now, and it's not all just big government contracts. We actually have companies starting up, and that's very, very exciting. So I have a question for MDA and synthetic aperture radar, benefits that you feel really aren't being fully utilized yet. So, why is there such an appetite for this stuff? And are there any things on the horizon that you think will be future applications for your RADARSAT?
Yeah, and there's different types of applications that have evolved, and they sort of, the types of satellites we're developing tend to be engineered towards those applications. So for example, Canada in the RADARSAT programs is really focused on the wide area surveillance type satellites. Why? Because they were developed around maritime surveillance, around monitoring large areas, and so the satellites were designed for that. But that doesn't limit it just to those applications. So some of the exciting things are around things like interferometry, where we're able to measure things from the radar data that you just can't measure any other way. So it's quite remarkable. For me personally, it was really interesting. When I was in grad school, I was involved in some of the early algorithm development around satellite interferometry, and you'd spend months and months and months working on one data set to try to eke out some results that you then write a paper about and go and present at a few conferences. And then when I was away in working in the US for a few years for MDA, and when I came back, I started working with the part of MDA that does that operation. Every day, they're doing the satellite interferometry for many, many customers. It's a commercial business. And I got to walk into that office and watch the operators doing that, doing something in about an hour that I took, 6 months to do during my master's degree, and then selling it to somebody for money because people were really seeing value in that. So this evolution, it's almost impossible to predict what all those applications are going to be because creative minds keep coming up with new ways to apply the data.
That's an amazing story. Alexei actually asked something that's sort of related, so I'll throw that to Mina and to Eric. What industries are not currently using space solutions that you think will be turning to them in the next maybe 10 years? Any you can think of? Aside from internet in space, I mean, who knew, take my phone when I go up on Virgin Galactic and you'll be providing my internet for me? Is that?
Well, I think you already hit on the big one, right? It's space tourism and the use of private space habitats. I don't think too many people are aware that there exists now a private space habitat mounted to the International Space Station, commercially done, start to finish. And that, between that and space tourism, those are uses of space we wouldn't have envisioned, and they're coming out live sooner than in the next 10 years. Oh, and one more, rendezvous and active support of nearly defunct satellites. So these are satellites that are looking for mission and life extension, and you have additional vehicles that are docking with them to go out and extend their lives or provide new services that they otherwise wouldn't have.
Excellent. I wasn't aware of that private space habitat. I'm really glad I wasn't. Now I've got to start saving up, I guess. Eric, do you have any thoughts about that? New applications for space technology?
One of the interesting ones that hasn't been talked about in a very long time is, back in the day, a really long time ago, when they were just trying to justify things like the International Space Station,
right,
was the idea of manufacturing in space, that we were going to build these humongo crystals in space or have the ultra pure pharmaceuticals. And I think that's still a thing. But what is interesting, I think it speaks to Mina's point about why we need to be fleet-footed in terms of applying new technologies, is that a lot of that took so long to do that we really have a lesser need for very big crystals and to do X-ray crystallography on them because we have atomic force microscopes, and it's fine. But what has been exciting, and what these new space initiatives and the lower launch costs, is that is basically coming up with new applications. And the one that I am personally quite excited about, this is obviously not GHGSat's business, but the idea of space solar power, of this just sort of endless clean energy from solar power satellites in orbit being beamed down to Earth. And this is, again, something that's been kicked around for decades, and it's outside of my area of expertise, but beyond casual interest. But I do understand that some of the technologies and some of the costs associated with that are also moving in the direction that this could be something we might see in the years and decades to come.
Right. So the title of our program was bringing these space applications, bringing the benefits down to Earth. And I think we've talked in some general terms. But there are some, things that are perhaps maybe on the edges of what we would consider. Things like following unregistered ships, or somebody mentioned using radar sat data to identify a lost Mayan ruin, whether or not that was real or not. There's some debate about that, remote archaeology. Is there anything out there that you maybe think is a little less on people's radar about what's space being used for? I may not have phrased that very well, but
Well, I mean,
space technology on stuff that maybe we wouldn't consider as using space technology. Yeah.
You mentioned illegal fishing.
Mm-hmm.
And illegal fishing, it turns out, is a massive problem as I've learned more about it. And it's a type of problem that is well suited for space applications because of the fact it's over vast areas of ocean, and it's very difficult to be keeping your eye on everything that's going on if you're based on the ground, even, or if you're just using aircraft. We're executing a project right now with the Department of Fisheries and Oceans, which is essentially using radar and other sensors in order to try to find vessels that don't want to be found. There's a very strong legal fishing industry where the vessels report in, so they, a fishing monitoring center knows where the vessels are because they're voluntarily reporting in. The challenge is the vessels that don't play by the rules, and how do you find those? Because if they're not voluntarily reporting in, the only way to find them is to actually, discover them through some other means. So using radar satellites is one such means, because as I mentioned in my presentation, it's very good at detecting ships. But we're also realizing that it's not the only answer. There are other types of satellite applications as well. For example, one of the areas that's being pioneered in satellites right now commercially is doing RF detection, so radio frequency detection from satellites. So this is listening for ships' radars, for ship communication transmissions, and finding what we call dark vessels that way. We call it a dark vessel is one that doesn't want to be found. So whether you're beaming some radar energy off the side of it, or you're listening for it, its radar itself transmissions, these are all ways you try to identify those vessels. And then what you do is you end up with a picture that says, here's all the vessels that I know. Oh, and here's, I've correlated all the radar returns with the ones that are reporting. Oh, what are these two doing? They don't seem to be correlated with any known transmission or a signal. Those are the so-called dark vessels, and then the fisheries authorities can send their vessel or send their aircraft to go and specifically to investigate those, rather than flying around in patterns trying to catch somebody. And what we've seen implementing that is that it's a little bit like a speed trap on a highway. You don't have to catch everybody, you just have to catch a few, and then people know you're watching, and then suddenly the amount of illegal fishing in that region drops. And then of course they're moving off to another region, so then you got to go and monitor that next region. But you can have very effective results from the satellite monitoring of illegal fishing.
So, okay, that's something I hadn't thought about, catching illegal poaching, basically, illegal fishing from space. That must be quite the, tap on the shoulder. Like, what are you doing? How did you find out? Well, our satellite caught you. I mean, that's pretty incredible. that's major spy stuff. That's very neat. Any other thoughts on that one? Sort of unconventional uses of space? I mean, that's got to take probably the cake, Somebody, yeah.
The other one that fascinated me, this is again back in the radar domain, is illegal bilge dumping of ships at sea. It turns out this is a major source of oil pollution in the world. We hear about the big ones, right? The Deepwater Horizon, the Exxon Valdez, but actually the chronic problem is just more mundane cleaning of bilges, dumping oily waste into the water, which happens with ships on international routes all the time.
Right.
And so countries have started using satellites in order to try to catch that and prosecute that. And Canada has a program called iStop, which uses the RadarSat satellites for doing exactly that. So they're monitoring and trying to correlate, again, information from other sources. So automatic identification system, long-range identification and tracking. These are all ship-based communication systems that are used to identify ships on the ocean. Trying to correlate that with radar signatures of oil slicks on the water to figure out who was it who did that. And then if they can do that, the interesting thing that was explained to me is they can then go and actually fingerprint that ship. They can go take a sample on the water and then go to the ship that they think did it and go and check the bilge water and actually compare it to say, yeah, this was the guy who did it. So really fascinating stuff, but it starts with, first seeing what's going on, and that's where the satellites give you some perspective.
I just want to say I wouldn't want that job. Yes, Eric.
I'd actually like to mention one more application, and that is satellites in the service of search and rescue. And this is something that Canada has been involved in decades, going back literally to the 1970s. There is an international consortium rather called COSPAS-SARSAT, and Canada was one of the 4 founders of that, along with what was then the Soviet Union, Russia, the United States, and France. And the idea here is that they put receivers, they put transponders on low Earth orbit satellites that would pick up the distress signals from emergency locator transmitters from ships or aircraft in distress and relay them to the appropriate search and rescue authorities to save these people. And this is a system over the course of decades that has literally saved thousands of lives. And Canada is at the forefront of that. Up to today, we are now in a generation called NEOSAR, which MDA has the contract with the Department of National Defense, and we're going to put these search and rescue repeaters on the next generation, the Block 3 of the American GPS constellation.
Absolutely. So if you're out at sea or elsewhere and you use one of those beacons in the future that goes up to a GPS 3 satellite and relays back, you're being saved by some equipment that was built in Montreal.
Incredible. Who by the way, is leading the Maple Leafs in the hockey game, if you're interested. I just happened to notice. Sorry. I wanted to get to a couple of technical questions because we still have some technical people on? I'm sure we do. So in the GHGSat infrared images, the satellite images that you showed seem to be overlaid on images from different instruments. And the comment was that it seemed to be very accurate matching between the two. How do you generally work in consort with imagery from other satellites? And if so, would you like to comment on that a little bit, or is it proprietary?
No, it's not proprietary. I'd be happy to talk about that. So the pictures that I showed in the presentation were basically ones that we show for public viewing. So for the sake of clarity, we'll take an image from like Google Earth or Bing or something, and we overlay it on top. What we do have on board our satellites, I should have perhaps mentioned earlier, is that in addition to the shortwave infrared Fabry-Perot spectrometer, there is actually a visible light imager on that. So we can geolocate the plume detections ourselves, and we also have a GPS receivers both for orbit determination and for location of images as well. So you are correct that we do know where those plumes are to a good degree of accuracy.
Excellent. Okay, and Mina, wondering, there's a couple of questions about deploying updated code to satellites once they're up in orbit, and also what happens when you refresh your satellites, getting back to that deorbit question.
No, for sure. So our satellites are all software programmable. We try to think of them like big computers up into low Earth orbit. Anything that goes up there is continually refreshed with new software on like a monthly to every quarter type basis. And we do lots of analysis simulation on Earth with mock-up satellites to make sure what code we launch up there can't destroy the satellite. And a general rule of thumb is the satellites are built in such a way that nothing we do from Earth could cause the satellite to stop working up into orbit. That's kind of built into all the designs and the work that we do. And then the second question around being able to refresh our satellites, so they don't actually deorbit within that 5-year period. Basically, we draw an analysis around, does it make sense for us to continue to use a satellite? An example case is batteries. They degrade with their usage every time you charge and discharge them. They become a little bit less useful as you continue to go out and take advantage of your phone, for example. In the same case, we think about our satellites. So we think about our satellites, and if their batteries are running low on their efficiency or things like that, we might want to replenish them with something else that is more useful, or we've got an update in our processors or our memory. We go out and we want to put that update out there, and then we do orbit our satellites within roughly a 12-year period to get them back down to Earth. They entirely burn up in Earth's atmosphere. They don't leave any remnants behind since they're so small, and they don't make use of any materials that can survive re-entry.
Great. So we don't have to worry about, bringing an umbrella out when they're coming down. That's all very good. I had again, because we had so many graduates here, there was a really interesting question that I'd like to put to all of you. What are the most employable skills new graduates might demonstrate if they were trying to go after a job in the space industry? Who wants to take that one on?
So the good news at the start is that it's very, very broad now. Like, gone are the days where you just think of someone in the space industry as being an engineer working in a lab, because it's become so commercial, so entrepreneurial. There's across the spectrum of potential occupations you can think of probably being needed in the space industry, just because of the nature of the way the industry has evolved.
Excellent. Yep, that's good news.
So if you're a good marketer, if you're a good accountant, a good lawyer, all those are things that are needed in addition to engineers.
Is there a particular sort of type of person who works in the space industry? You say good lawyer, good whatever, but do you find that everybody's a Star Trek fan or what?
No, I'd say it takes all types. Again, it's evolved over time, and I think you have people who are genuinely excited about the idea of space, and it's an interesting thing, right? It's one of these things where you do your day-to-day job, and it's filled with all the things that are typical of a day-to-day job. But every now and then you kind of got to step back and go, wow, this is really cool, like what we're doing. And to me, it usually happens when I'm trying to explain what I'm doing to somebody else outside of the company, and you sort of realize as you're explaining it that this isn't typical. Like this is really exciting stuff that you're doing that is not typical and not necessarily found in other jobs. And so it's important that we remember that. And I think the type of people who work in the space industry are ones who get excited by that.
Mina and Eric, do you have any thoughts about that? The kind of people you surround yourself with all day long? Not right now, I guess, but virtually anyway. Sorry, go ahead.
No, I think for us at Kepler, really like the core attribute we really care about is people who want to become masters of their art, whatever their art might be. So if your art is accounting, if your art is RF engineering or regulatory frameworks, you just want to be really great at it. You want to surround yourself by the best in the field, and you want to become exceptional at it. It's not to say that you have to do that one thing through the course of your life, but it is to say that you want to be great at it. And that's probably like the single most important attribute that we look for when we're bringing people on board. And it's not necessarily that they have to come from a space background or a space heritage, because like Ian said, we've got such a diverse set of skills and people that we employ nowadays, from manufacturing to marketing to sales to finance and across the board. So it just has to be that they're really passionate about what their art is and they want to be exceptional at it.
Very nice. I think that may be the signature of a maturing industry then. And Eric, you spoke very passionately about, the ethics of Star Trek universe. Sorry to keep going back about that, but I'm a big Trekkie too. And how you feel like you can contribute to that betterment of the world and certainly betterment of Canada by the work that you're doing now. Do you find that that is something that is sort of not maybe rare, but do you find the people that are working at GHGSat share that passion, or are they just really, interested in getting into space, or is it a combination of both, do you think?
I think it's a combination of all of those things, and it touches on all of the factors that Mina and Ian have already touched on in terms of the type of people that we're looking for. So maybe if I could go back to a wonderful piece of advice a heck of a long time ago when I wasn't even in university. I was looking at going into university. And this person was somebody who was working in the US space industry. And he said to me that the purpose of university is not to teach you how to do a job, is to teach you to figure out how to do a job. And that flexibility, that open-mindedness, that desire and drive to take ownership of of a challenge, and to meet it with dedication and joy and hard and some elbow grease. Regardless of who you are, whether you're an engineer, whether you're a contracts person, I can tell you the contracts person is one of the most important people in our company right now. These are the qualities and these are the people that we're looking for. These are the people that are going to heal our planet, and the people that are going to take us to the stars.
Wow. I think that's a fantastic place to wind down our discussion this evening, but I have one last question for you. Would you all be interested in coming back about a year from now and telling us how things are going?
Absolutely.
Yeah, that would be
anytime.
That would be fantastic, because I think there's some really exciting things going on here. I've been following the space industry in Canada for a while, and it's been apparent to me for about the last decade that it's just coming along by leaps and bounds. And now all of a sudden, here we are in the midst of this massive growth. And I find it fascinating and very heartening to see that it's in such good hands and the very thoughtful people. And we're not just chucking stuff out there for the fun of it. It's all got really good purpose and is helping us back down here on Earth. So on behalf of Space Place, I'd like to thank you all very much for giving your time this evening. I know there were a lot of people who had questions. We may not have gotten to them all. So if you're still watching on YouTube, if you want to send any follow-up questions, I can pass along to our speakers tonight if they seem relevant. We can do that, or we can perhaps shout out on Twitter and try to catch you that way. Speaking of which, if you want to stay connected with Space Place, we have a lot of social media, old people's social media, even Facebook. So I'm gonna call it that for the rest. My kids just, that'll be perfect. So please do, and please look up our speakers, their companies, GHGSat, Kepler, and MDA. The links to those are all actually on the listing for this event, so you can find out more about them and follow along and see how their missions are going. And again, thank you very much for joining us tonight. I'm going to leave the screen now and invite our chair, Henry Lowton, up to say a few closing words. Here we go.
Thank you very, very much, Kirsten. And thank you once again to our speakers, Eric, Mina, and Ian. It has been a delight. We learned a lot. I wanted to just say hello to everyone as president and co-chair of Space Place Canada, to let everyone know who we are, to remind everyone, thanking them, by the way, for seeing us in addition to watching the Toronto-Montreal game. But to have us as part of their evening. Space Place Canada is a nonprofit comprised of professionals and students from across North America determined to create a virtual planetarium for the world and a 21st century physical planetarium, public planetarium for Toronto, supporting STEAM, science, technology, engineering, arts, and mathematics, education, careers, and recruitment in Canada. Every day will be Career Day at Space Place Canada. Toronto has not had a public planetarium since 1995, and the city is the largest without one. A critical missing piece in our tourist and educational infrastructure. While we explore prospects for a physical location, we hope to have exciting news very soon. We are engaging supporters and virtual communities in our virtual event series on our YouTube channel that you're watching today. Our next event is the Business of Space, Opportunities for Canada, and we are still tinkering with a pithy title, which we hope to have in mid-June, and we will seek to make a business case for the opportunities for investors, institutions, and individuals scoping opportunities in the sector, and to outline in greater detail the opportunities for future careers as well as investment opportunities. So we hope to have details of that to share with you shortly. As mentioned by Kirsten, we do have opportunities to be engaged in Spaceplace, and we encourage people to write us at info@spaceplacecanada.ca about membership, and also inquire about our Spaceplace swag, our planetarium music card, our Spaceplace face mask, and our book by Bob McDonald, which outlines his great vision, Earthling's Guide for Outer Space. Thank you very much, and I hope I can turn it back to Kirsten to say thank you once again. We hope to see you again soon.
Thanks, Henry. Well, that's it for tonight. I hope we see many of you in June when we announce that next event. You can follow us at Spaceplace CDA on Twitter and spaceplacecanada.ca for our website. You can also connect with us there, join, perhaps sign up to a newsletter and get information about what we're doing next. We do hope to see you soon and hope one day under a real planetarium dome. Thank you very much. Have a good evening.